Welcome everyone. Today we are diving into one of the most fascinating sorting algorithms out there, shell sort. Ever wondered how we can make simple sorting methods like insertion sort much more efficient? That's exactly what shell sort does. In this video, we are going to break down shell sort from the ground up. We will explore the brilliant idea behind it. How sorting elements that are far apart first can dramatically speed up the entire process. I will walk you through exactly how it works step by step with clear examples and visualizations. What makes shell sort so special is it is used for gaps or intervals to compare elements that aren't just next to each other. We will see how starting with large gaps and gradually reducing them creates a much more efficient sorting strategy, especially for larger data sets. This isn't just theory, we are going to implement it together, analyze its performance, and compare into other sorting algorithms. By the end of this video, you will not only understand how shell sort works, but also why it is such an important concept in computer science. So, whether you are a student preparing for an exam, a programmer looking to optimize your code, or just curious about algorithms, this video is for you. Don't forget to like, subscribe, and hit that notification bell so you don't miss any of our algorithm deep dives. Let's get started. What is shell sort? Shell sort is an optimized version of insertion sort that works by sorting elements that are far apart first, then progressively reducing the gap between elements being compared. It's also known as dimension increment sort. First, shell sort is an in-place comparison sorting algorithm, which means it sorts the elements within the same array without using extra memory. Second, shell sort is mainly a variation of insertion sort and bubble sort. It improves insertion sort by allowing comparisons between elements that are far apart, instead of only adjustment elements. Third, this algorithm reduces the large shifts that occur in insertion sort. By using gaps, smaller elements move quickly toward the beginning of the array, making the sorting process faster and more efficient. Shell sort is a unique sorting algorithm designed to improve upon similar methods like insertion sort and bubble sort by allowing elements that are far apart in the array to be compared and swapped early in the process. The key innovation is the use of an interval or gap that determines how many positions apart elements should be when comparing them. This approach is particularly effective for large arrays where smaller values might be positions near the end, as these values can be moved much more quickly toward their correct positions at the beginning of the array through these gap-based comparisons by gradually reducing the gap size with each iteration, starting with large gaps to move distant elements efficiently and ending with a gap of 1 for final adjustments. Shell sort achieves performance that's standard insertion sort, especially for larger datasets where elements need to travel longer distance to reach their sorted positions. So the optimal shell sort sequence this so when in n is 8, the first interval that is going to come out will be 8 divided by 2. Which will be 4, second interval will be 8 divided by 4. which is going to be 2, and the third interval is going to be 8 divided by 8, which is going to be first. It is confusing, don't worry. Shell sort is an enhanced version of insertion sort that sorts elements by comparing items that are far apart first, then progressively reducing the gap between elements being compared. Main idea: move out of place elements long distance early in the process so they get closer to their correct position faster. Shell sort is an optimized version of the insertion sort that works by sorting elements that are far apart first, then progressively reducing the gap between elements starting with our array 9, 8, 3, 7, 5 and 6. We first set our gap to 4 and compare elements 4 positions apart. We swap 9 and 5. Swap 8 and 6, leave 3 and 4. As there are and swap 7 and 1, result in 5, 6, 3, 1, 9, 8, 4 and 7. Next, we reduce the gap to 2 and sort elements 2 positions apart by creating 2 separate groups. Indicates 0, 0, 2, 4 and 6 with values 5, 3, 9 and 4. Becomes 3, 4, 5 and 9 after sorting and indicates 1, 3, 5 and 7. With values 6, 1, 8, 7 becomes 1, 6, 7, 8. When we recombine these groups, we get 3, 1, 4, 6, 5, 7, 9 and 8. Finally, with a gap of 1, we perform a standard insertion sort. Swapping 3 and 1 gives us 1, 3, 4 and 6. Then, swapping 6 and 5 gives a 3, 4, 5, 6, 7 and 9, 8. And finally, swapping 9 and 8 gives us our completely sorted array 1, 3, 4, 5, 6, 7 and 8 and 9. This method is efficient because it moves elements long distance early on, getting them closer to their correct positions faster than regular insertion sort, which only compares adjustment elements. Shell sort is an improved version of insertion sort. It started by comparing elements that are far apart using a gap and sort them. As the gap gets smaller, the array becomes more sorted, allowing smaller elements to move faster to the beginning. When the gap is 1, the array is fully sorted. This method reduces the number of shifts and makes sorting more efficient. Thank you so much for watching. If you found this explanation helpful, please give this video a thumbs up. It really helps the channel grow and reach more curious minds like yours. Don't forget to subscribe and hit the notification bell so you never miss when I upload a new deep dive into algorithms, coding or computer science concepts. Leave a comment below, let me know what topic you are like me to cover next, or if you have any questions about shell sort. I read every single comment and love hearing from you. Thanks again for your time. Keep learning, keep coding, and I will see you in the next video. Next we will show the code demonstration. This program demonstrates how shell sort works using Java. Shell sort is an improved version of insertion sort that uses a gap to compare elements far apart. We define a class named shell sort example. This class contains all the methods related to the shell sort program. Then we create a static method called shell sort. This method accepts an integer array as a parameter and sort it using the shell sort algorithm. Next, we store the length of the array in a variable. This value is used to control the loops and calculate the gap size. Then we started the outer loop to control the gap. At first, the gap is half of the array size. After each iteration, the gap is reduced by half until it becomes. Next, inside the gap loop, we are another loop to traverse the array. This loop is started from the current gap and moves forward through the array. Then we store the current element in a temporary variable. This value will be placed in its correct position after shifting. We assign the current index to another variable. This variable is used to move backward in the array while comparing elements. Then we use a while loop to shift elements. This checks whether the previous element based on the gap is greater than this current value. If the condition is true, the large element is shifted forward. This creates a space for the small value. Then we reduce index by the gap value. This allows us to continue comparing previous element. Next, after shifting is complete, we place the value in a correct position. This completes one step of the gap insertion sort. After finishing all gap values, the array becomes fully sorted. We define the main method where the program starts execution. We create an integer array with unsorted value. We print the array before sorting. Then we use a for each loop to display each element. We call the shell sort method. This sorts the array using the shell sort algorithm. We print the sorted array. Finally, we use another for each loop to display the sorted value.